Hello, hello, hello. If everyone can take a seat, we're going to get going with the program. So please wrap up those conversations and take a seat. Get your coffee. We're going to get going. So if you can hear me, clap once. Or clap twice. All right, come on, guys. We're gonna get going. So wrap up those conversations. Everybody in. Have a seat. Don't be afraid to sit near the front. All right. Well, hello, everyone. I'm Christine McGowan. I'm with the Vermont Sustainable Jobs Fund, and we've been hosting this summit for since 2018, and we're really excited that you're here. And I want to just say thank you to Bolton Valley for hosting us here. It's a beautiful Juneteenth, which is a day that we honor and celebrate freedom for everyone. We're going to be in this room, the Ponds, for the morning. So there's coffee and some food, so please get comfortable. Just for those of you who haven't been in here, there are bathrooms behind me off into the little alcove, so feel free to use those. So we're going to be in here through the lunch, and then after the lunch and extended networking time, we are going to move over across the road to Timberline, and that's where we're going to have our afternoon breakout sessions, a fireside chat, and then we'll wrap things up with a cash bar and some snacks. For those of you who need Wi-Fi, there is a QR code off right on that wall to access the Bolton Wi-Fi if you need it. And so this year, we have extended some of the networking. We got some feedback that we wanted more networking time. And we want to be able to network with our amazing exhibitors who are all across this wall over here. So when you walked in, you got a passport. And what we would like you to do is visit all of our exhibitors. They really want to talk to you. So what you'll do is you go over, you say hello, you find out what they're all about, and then they have a marker, and they're going to make a check mark, or I guess they're I don't know. They're going to make a mark on your passport, and you're going to you're going to visit all of them. And then when you get all of them done, you're going to, before we leave for over across the street, you're going to drop those cards in a box, and then after our fireside chat, we are going to draw for some giveaways. And we've got some really great giveaways that we will talk about later, but we're excited about that. So please do talk to those exhibitors. Okay, for those of you who are looking for SAF or LEAP credits, again, at registration, just make sure you have signed up for those. Those are available for today. All of our sessions are going to be recorded, and then probably within a few weeks of the event, we'll make those available on our website. So if you won't be able to get to all of the breakout sessions, but they are recorded, so you'll be able to go back and look at them. And we also have Mansfield Media will be roaming around. They've got some cameras, and they're working on another project. They did a really great documentary about the industry a year or so ago, and they are following up on that. So they may be asking some of you to do a quick interview. They're going to get some B-roll, so just know that they are floating around. And finally, we have with us, you may have seen a service dog named Benny. He's here with his handler, and he's very friendly, but he is not to be petted. He is on duty, so we just ask that you not pet Benny. Okay, so I want to, before we get started, thank some of the sponsors and funders that make this event possible. So we have some wonderful sponsors today. Our Pine Level sponsors are Farm Credit East, the Northern Forest Center, Professional Logging Contractors of the Northeast. They are also an exhibitor over in the corner. Please go visit Dana. Vermont Wildwoods, Vermont Woodworks Council, they're also here as an exhibitor, and Weyerhaeuser. So I want to give a big shout out to them because really their support really makes this event possible. We also have a couple of Maple level sponsors. This is a new thing for us. And so we have two of them, and they're actually going to speak to you in a few moments. I'll introduce them shortly. But we really appreciate that support. And I also want to recognize the funders that really make all of this possible. First and foremost, the Working Lands Enterprise Initiative. They are a huge supporter of this event, have been for many years, and they've been a supporter of really this whole industry and making sure that our forest economy is thriving. So I want to give a big thank you to them, and also the Northern Border Regional Commission. The work that I do and our organization does works in partnership with several different grantees, and I just want to say thank you to those partners. UNH Extension, we are working on a project with them, and Andy Fast, who is somewhere in the room, working on helping to get local species into the mass timber world. So really appreciate that support. Also, we are a partner with the Vermont Department of Forest, Parks, and Recreation. They have an NBRC grant that is helping to support the Vermont Forest Future Strategic Roadmap. So I know a number of you have been involved in that, but if you don't know or you want more information about that, I know they are here as an exhibitor and can share more with you. So again, great to be able to partner with them. And then finally, Vermont State University, we have recently partnered with them to take over the management of the Forest Business Accelerator. So my colleague Kurt is over here at our table, and he can talk more about that accelerator. And we also have one of our consultants, Judy Giordan, who is floating, there she is in the green. So if you have questions, I don't have time to talk too much about it, but it's an exciting new program that is really offering support to innovators and entrepreneurs in the forest economy, and we're really excited that we're about to pick the 2025 cohort. So by the end of this month, we will have selected 8 companies, we hope, who will participate this fall in a 4-month intensive program. So more on that later, but if you have questions, just ask Kurt or ask Judy or myself or Ellen Kaler. We're happy to talk about it, and we're very excited to share more. Okay, so speaking of innovation, the theme of today is innovation in our forest economy. And I know some people say, that word gets overused, but actually it really, I like to think about this because when you think about the definition, to make changes in something established, especially by introducing new methods, ideas, or products. And so that is really the theme of what we're talking about today, and a lot of the speakers and the topics that we'll be discussing really do center on this idea of how do we innovate, how do we make changes that can make improvements to what we are doing. And part of that is to be inquisitive, to not be afraid to fail, and to really try to think about, like, what does that future look like? So I want you to take a breath, appreciate the fact that you've decided to take a day out of your busy schedule to be here. So enjoy that and really take advantage of all the content that's going to be coming at you today and that you will be participating in. So very excited about that, and just want to thank you all for being here. So with that, I am going to introduce our first Maple Level sponsor, and that is Cambium Carbon. And so Talia Stewart with Cambium is going to say a few words to you, and I'm going to turn things over to her.
Good morning, everyone. Thank you so much for being here. My name is Talia Stewart, and I am a regional manager for Cambium. Cambium, we are using technology to revolutionize the forest product supply chain, creating local circular systems that prioritize sustainability, transparency, and impact. There's a lot I could say about how we do this, but I only have 5 minutes, so instead I would like to tell you a story. There you go. The main character of our story is Eastern white pine, Pinus strobus, quiet giant of our forests and a pillar in our community's economy and ecology. White pines live more than 200 years. They grow more than 100 feet tall. So what do we do with it when it's time for it to come down? For many trees in urban and peri-urban areas, the end isn't noble. They're often chipped or burned or brought to landfill, and this can cost the company that removed them money. In this process, the carbon stored in the wood is lost, and any remaining value is lost. So it's a broken end to the story. So at Cambium, we're imagining a better end. We work to salvage these trees from waste stream and create real, lasting value. So let's follow the journey of one such pine tree that was felled by a tree service in New Hampshire. Rather than let it go to waste, they partnered with Mill Market, Cambium's supply and logistics arm. Yep, that's the one. Okay. So in this case, a supplier in Epping, New Hampshire called us about a load of white pine. This is a white pine being chipped. I'm clicking. Well, in any case, they called us about a load of white pine, and we posted it on load board, which you will eventually see up here. A driver who was hauling lumber south from Quebec claimed it for a backhaul, and they delivered it to a sawmill in Quebec, Saint-Ephrem-de-Beauce, Claremont, Amel. There they saw pine, hemlock, and spruce into dimensional lumber, beams, timber framing, all products that will store carbon for decades and support local economies on both sides of the border. Our pine had an even more exciting destiny. Our pine became part of the Cambium Campfire Coil, a mass timber art installation unveiled at this year's International Mass Timber Conference. Hey, there we go. Okay, so this is load board. I'd like to tell you a little bit more about this if I can. So how Mill Market works is we partner with suppliers, primarily tree care professionals that aren't tied into the traditional supply chain. They prep and pile logs as they come in, and when they have a truck full, they call us, and we work with truckers who can scroll load board at their leisure and claim hauls. We also work with sawmills who purchase the logs. So we're able to provide the supply and the demand and detailed tracking information all along the way. All right. So that's the truck picking up the logs, delivering it to the sawmill in Quebec. This one? Oh, there we go. Okay, perfect. So our pine became part of the Cambium Campfire Coil, a mass timber art installation. The coil was designed to inspire community and connection and storytelling. It celebrates the beauty and strength of this local material and serves as a tangible representation of the continuity and circularity in our regenerative forest ecosystems and the products we make from them. But mass timber is more than a medium for art. It's a material with extraordinary potential to store carbon and to replace carbon-intensive building materials and structural applications. And we're seeing that play out in real life. We have a major tech client building a 2 million board foot mass timber warehouse completely built out of salvaged southern yellow pine. So this isn't theoretical. This is scalable, and it's already in motion. This pine went from being potential waste to being the centerpiece of innovation, storing carbon, showcasing the potential of mass timber, and honoring the full life cycle of our forest resources, all while maintaining transparency and traceability. This is what we're doing at Cambium. We're working to make better endings for trees, ones that support local communities, steward the land, and open new pathways for sustainable growth. So thank you guys so much for being here. Come chat with us. We're really excited.
Thank you so much, Talia. We really appreciate you being here. Okay, so we are going to change it up and have our keynote speaker So I'm not going to do a whole big introduction of Alan Organschi because you have his bio, and it's on the website, and you have it if you grabbed one earlier. So you can read more about his illustrious career. But I just wanted to just say a little bit about how I met Alan and why I thought it was really important for him to be here. So Alan and I met, I want to say, maybe 2018 or so at the Mass Timber Conference out in Portland, Oregon. And I remember, I think it was Ricky McLean, who is somewhere in this room, who introduced us. And I remember having a conversation with Alan and just thinking, oh my gosh, wow, he really gets it. He really understands this whole supply chain. And it was just really fun to talk to him, interesting, and I felt like we had an instant connection. And then I saw him speak, and I thought again, like, wow, he really understands what is happening writ large. He is a big thinker when it comes to all of the complicated but also exciting parts about the forest economy and how it connects to the way we build. So I have wanted him to come here for a while, but he's a pretty busy guy. He is a world traveler. He is in demand in many parts of the world. So we are really, really honored that he has taken time out of his schedule to come up to Vermont, which I know he loves Vermont, so maybe that helped, to come and share some of his wisdom with all of you. So with that, I'm just gonna have Alan come on up and take things away.
I'm gonna use the, is this working? Okay. Christine, thank you. I felt the same way about you, by the way. So, and thanks to Ellen and Esther and all the people who made this possible. It's a great event. So here we are in amazingly beautiful, beloved Vermont. And so I thought, as counterpoint, I might talk about something the exact opposite. Tokyo, which is as we know, the largest, most populous, continuous megalopolis in the world, right? It's the exact opposite of forests, you could say. Industrial ecologists who work on material flow through industry manufacturing will tell us also that not only is it the most populous area with the largest stockpile of humans, it's the largest stockpile of human-made material, the densest, largest stockpile of human-made material in the world. And that collection of material has a whole set of impacts. Do I point it this way? Okay, so if I start gesticulating wildly, you know why. And I don't need to list these here, but they start with the impacts on the city and city dwellers, but also these remote impacts that happen far beyond the city boundaries, as large as they are, of Tokyo, in remote landscapes from which we extract resources to make these buildings, energy, material. And they have huge impacts on ecosystems, especially the classes of mineral-based materials that are fossil energy manufactured that produce cities like Tokyo and, frankly, most of the cities of the world. So what I'd like to do is consider this fact, which we face right now, even though we may be working in forests in Vermont and the Northeast. We're going to build 2.5 billion people's worth of housing, infrastructure, workspaces in cities in the next 25 years. That's going to double the building stock that currently exists on the planet. If we continue to build with these sort of low-density morphologies with which we currently build human settlement, sprawl, it's going to consume 3 times the land area that human settlement currently uses. And that's really good news for the construction sector. This is a building that's the size of the entirety of New York State, or for any Europeans in the audience, 2 Irelands or Asians, 4 Bhutans. And I'm not talking about a city that size. I'm talking about a building the size of New York. That's great news for the construction sector, as I said, $97 trillion worth of building that we'll be building in the next 25 years. But what we build and how we build it will affect the future of the planet. So I think we conservatively estimate that of all annual anthropogenic human-made carbon emissions, 42% is associated or caused by the building sector activities and artifacts. How we make the stuff, how we operate our buildings, and what we do with them at the end of the building life cycle. Usually we landfill them. The really scary part is that by 2050, half of those emissions associated with building and buildings will be caused by the production process of building. The energy that goes into extracting the material, manufacturing it, transporting it, processing it again, building. And by the time 2050 rolls around, super efficient buildings will have never paid off through offsets the debt that we've incurred during that production phase of building. This is really stark, and industrial ecologists who study this stuff will tell you that it's a dead end for the climate. So we have to really focus on cities, and we've ignored them. We thought a lot about building energy and energy consumption, and now more and more carbon emissions, but really we have to think about what we make and what we consume. So this is really a relationship between two landscapes. Let's let the forest stand in for natural systems, natural ecosystems, and the city, which has, frankly, up to this point, consumed the forest in the least efficient and productive ways. It's just converted land. And somewhere, because of that huge building boom we're about to face, we will produce an even larger hole in the surface of the planet with huge emissions. And again, half of the emissions of the building sector, which equates with 25% or a quarter of the emissions that we produce as a species, are associated with what we build in the next 25 years. About 5 years ago, we passed a really important threshold. Suddenly, we realized that all the stuff we produce and consume weighs more than all the biomass on the planet. So that's a pretty important thing. Really, since the Carboniferous era, a couple 100 million years ago, we've had a pretty steady amount of biomass on the planet. And suddenly, in 2020, the stuff we make weighs more than that. Another chilling thing to think about. Which brings me out of this prologue into the story that I want to tell today, which I think is close to all of our hearts, which is how do we create resilient forests, and how do we use really innovative structures that Christine mentioned to help us do that? Could we create a synergy between that city, all-consuming city, and forests? So I'm not going to talk about our architecture too much. I'm an architect and a builder, and I like to think we're innovative in the work that we do at GOA Architecture. And I'm certainly not going to tell a bunch of people who work in forests about woods architecture. But I want to talk about the architecture of the system that produces buildings. This is called the building life cycle. But really what it represents is all of those steps, operations, pieces of material that move through a process to make buildings, and ultimately where those materials go at the end of the building's life when we decide that it's not really useful anymore for us, and so we're going to tear it down. And you're all familiar with this. We're moving our way quickly through the guardrails that were set by the IPCC for sustainable carbon emissions. And pretty quickly, if we continue in a business as usual scenario, the planet will be less than habitable. I think rich people will probably be okay. It'll be stressful. Most of the population of the planet, human population, will be in a lot of trouble because of resource scarcity and all the effects of climate change that we're already starting to see. And then other species, God protect them, I don't really know what's going to happen to. There's a mass extinction we're facing. And the plan that currently exists for transsectoral decarbonization, where we're trying to kind of remove all of our emission, our great emitters from the plan, really just stabilizes us well above the 2 degree Celsius temperature guardrail that the IPCC set at the Paris Accords. So my question is there some way that we can actually not just mitigate our carbon emissions in the building sector, but actually reverse climate change? So let's look at the primary structural materials. Buildings aren't just primary structure, although this is a pretty good example of a building with great primary structure. There are a lot of different materials, but the bulk of the weight of a building is in the primary structure, the frames, panels, and systems. And if you compare the relative emissions of a ton of steel to a ton of concrete to a ton of wood, you start to see that wood has a real advantage. And then if you consider the strength to weight ratio of wood, which is really strong compared to steel and concrete, you realize that you get a huge benefit by using wood structure through reduced emissions. And then if you add what Talia mentioned, carbon storage and the capacity of buildings to these durable consumer products that we make that last for decades at least, that we can store carbon in them and they become sort of partners to forests in carbon storage, and then you start to see a huge advantage in building with wood. And we have a social license problem. People still think, when I go around the country and talk about this stuff, they still think we're cutting down, old growth forests to make toilet paper. So we have to address that. Because now really what we do is we use much smaller trees, and we basically take those small trees and we use very small pieces of them so that we can get better yields out of the trees rather than expecting solid wood. And we can make giant structures out of them. And actually, the fact that we have adhesives and that we have this really old technology called finger joining, we can re-engineer wood structures to create incredible structural components that now can be applied to large urban buildings and infrastructure. And the fact is that the glue laminating industry, as you probably all know, have long since the very inception of the glue lam taken the best material, the highest rated material, and put it at the most critical structural edges of, say, a beam. And then they use the lower grade stuff in the middle where the stresses aren't so great. And so now we've really optimized the material, because not only have we used smaller sticks that are coming out of maybe knotty or wood with certain defects, but we're actually able to take the really good stuff and make it do the work that we need. And we haven't even started really considering mixed species structural layup. This is a 5-story building in Switzerland by an amazing company called Bloomer Lehmann, where they're using beech laminated veneer as bearing plates and connectors to replace steel in a 5-story urban building. And the rest is European spruce, which has less bearing capacity but incredible tensile capacity. And so now we have all these techniques, mechanical, adhesive, to gang wood together into these large sections. We can create these entirely new structural systems for big buildings. And the IBC, the International Building Code, which is a reigning code in the US and Canada, but also extends through a lot of other countries, allows heavy timber, so-called mass timber, to build buildings up to 18 stories, which is a radical change. Suddenly we have capacity to use the size of cities to store carbon. And so the question that architects ask, and I don't mean to be critical of my profession, but how tall can we make a building out of wood? Well, most of the world is building buildings that are in their cities, 5 to 10 stories tall, which is a sweet spot, as we can see from the International Building Code. I don't personally want to spend my time designing a 80-story wood skyscraper. I think it's a great demonstration project, but we have some other fish to fry. And for those of us who are worried about, losing forests, let's really consider this. Let's consider all the kinds of disturbance that arise from human activity, pests, and climate change. Forest fires are the ones that are the greatest disturbance. Colleagues of mine at the Center for Applied Science Synthesis looked at this really carefully, and they said, great, if we have no disturbance scenarios at all on the planet, forests will continue to grow and thrive. There'll be no problem. But if we start to look at the disturbance scenarios that are caused just by climate change, the forest sink starts to collapse, which is another really grim scenario. And one of the things they looked at in certain forests, if we utilize forest products in ways that reflect regenerative silvicultural treatment, we start to see recovery of the forest. And we also have all these avoidance benefits. We don't use steel and concrete. We're building more carefully. We're not destroying the forest ecosystem. Forest loss, we know, is caused by a lot of factors, least of which, at the large economic scale, is the wood products industry. It's caused by beef cattle grazing land and new agricultural conversions. It's caused by mining. We take up forests to get to the minerals and the ores below the surface of the forest. It's caused by wood product use. About 15% globally is associated with of emissions, and forest loss are associated with forest product use, but a lot of that has to do with domestic heating and energy consumption. Suburbanization, sprawl, wipes out forests. And finally, as I mentioned, climate change itself. And with all of that, this extractive economic activity that is really the basis of contemporary building, so-called extractivism, hasn't met the needs of the planet in terms of creating architecture, safe housing. Everyone's talking about how, I had this conversation with Sean earlier, everyone's talking about a lack of housing. And meanwhile, we're consuming so much sharp sand, which is a constituent element of reinforced concrete and cement, that we're spawning criminal syndicates in mangrove forests extracting sand to meet the demands of Chinese and Indian concrete construction. And we're producing 70% of the waste, the building sector, 70% of the waste that's bespoiling the planet. Builders. And just wood, 30% of the wood that goes into a construction site as a new material goes out in a dumpster before the building is even occupied. So we have a waste problem. And that creates resource scarcity and a lot more social inequity. And did I mention extractivism? Not just material extractivism, but human slavery, which is, as I mentioned, buried way down in building supply chains. Okay, so now I want to be a little more positive. What if forests, which are these amazing metabolic, ecosystemic, regenerative systems, could be combined with urban building to create a kind of geotechnology? I'm talking about a really big scale that we can all participate in generating. So we wrote this paper called Buildings as a Global Carbon Sink. It was purely meant as a provocation with climate scientists and political economists and foresters and manufacturers and industrial ecologists. And we got it published in Nature Sustainability, which was a big deal for an architect because we don't publish scientific papers. And we said, what happens if we built all of those 25 years worth of buildings for 2.5 billion people out of biomaterial? What would be the carbon storage benefits? And it showed, as a provocation, that if we could possibly do that logistically, we would actually reverse climate change. Now, of course, the proviso is that we have to handle our forests really well and sustainably and carefully. And I won't tell you about the hell that was rained down on us for writing this paper. But the proposal was this. Imagine that we could look at the way forests grow, and at every stem succession stage, we could harvest out material that would create a certain set of habitats, and then as forests grew, we would get different materials, and we'd start to apply them through really inventive material systems. Sorry, my flow is broken here. We could start to understand how much carbon was maintained above and below ground in forests, and could we actually supplement that? And could we start to pull materials out and bring them into, yes, continuing low-rise construction, which we know how to do, but bring them into really dense urban construction, mid-rise urban construction, and you start to see below that sort of carbon transect, the base, how much carbon you get to store while forests are continually growing. So what would that take across this entire value chain? Who do we have to work on? So we put together a proposal with National Science Foundation, which was, I was told 4 days after I submitted this application that there was no funding available. Who would it take? And so we looked at all the people who I work with at Yale University, an incredible array of actors who literally touch all along the value chain, from forests to cities, the way we make buildings, and how we would then connect to city, state, regional actors who can help us in industry, in forestry. And what we found was that we could actually put together an actual supply chain, just starting in New Haven, Connecticut. And that involves all of you. So this is the part where I get to talk about my work a little bit. Our practice is a design, build, and research practice. And we actually started making bridges. In 1996, we made our first vehicular bridge out of glulam. For those of structural engineers in the audience, you'll know that we misunderstood how glulam works. So we took basically an arch and we flipped it over on its side to make a bridge. And over the years, we made a lot more bridges out in these incredible landscapes that had very low impact to the ecosystems in which they were working. And they got more complex. We started making suspension bridges. This is in Steep Rock Preserve, 3,500 acres of publicly accessible land in northwestern Connecticut. And now it's this beloved structure, although we had to fight all the people who didn't think we should put a bridge over a river in that particular location. And now we're working to make an almost 500-foot-long bridge along the Hudson River across the Metro North Railroad tracks and the highway that had separated all of us from this beautiful, pristine riverscape, using a combination of timber, steel, concrete, using the properties of each material in the optimum way to reduce the amount of impact that we create, to produce an access way at the Breakneck Ridge. If you ever get a chance to climb it, it's incredible. It's the other side of the river from Storm King Sculpture Park, to bring the largest population of hikers in the country who come up from New York City on the Metro North Railway and hike these trails. And now they have access to the Hudson River. So what's so great about building wood stuff in the woods? We know how to do that. We've been doing it forever. So the question is, can we start to actually create density in our city using materials like carbon storing timbers? And so we took a 4-story historical unreinforced masonry building in New Haven, Connecticut, right next to our office. And we proposed to build a 2-story addition on top of it to turn all of them into apartments and to essentially nearly double the capacity of units that we could put in that. And the way we made it work, because it didn't work with concrete or steel because the building had no reinforcement in it, it would collapse under the load, and the cost of reinforcing it with steel and concrete would make it impossible. We made a 7-story cross-laminated timber shaft for the elevator and the stair core. And then we locked that into 2-story addition on top of this 4-story building. And that alone made it possible to build that additional housing. And it was really something to thread a 7-story core down into an existing building. And it was the thing that makes it possible now in this city to build in a city with land scarcity but population demand for housing, to make more and more housing in historic districts. And so today, the building is finished, and the interiors are really nice, and they're fairly affordable, and they're made out of wood, which has huge benefits for interior air quality, by the way, compared to drywall and paint. And it's going to be home, this building, which was a furniture warehouse, is now going to be home to 25 households. But how do you really make this stuff work? Because everyone tells me, every developer I work with says, oh, we really like to use timber for our structure, but it's not affordable. Well, it's not affordable because you have to understand all of the benefits all along the value chain. And we made a deeply affordable housing project in New Haven, Connecticut, 70 units of housing for a neighborhood in which the citizens are completely disenfranchised, have huge housing scarcity problems. And some of the occupants of this will have a 0 area median income. And they'll be living in a building lined with wood. And this building is going to open in 2 months to, as I said, 70 families. It's entirely made out of bio-based materials, 4 stories tall. We were told that there's no way that we could possibly afford this. And what we said was, you really need to understand how to put a mass timber building together. It can't just be done like your old stick frame, light framing. You have to actually really align everything carefully, and the whole thing needs to be constructed so that you optimize the airtightness benefits of a monolithic structure. You can get good bio-based insulation on it. You can use cladding, which has good durability, and you can have an incredibly energy-efficient building because of all these things working together, which makes the life cycle cost of the building really, really high, or low, sorry. I hope you guys will forgive us for these clickers. They're a little funky, or I'm doing it wrong. But, and we proved that we could build a mass timber building, which is way better construction for almost as cheaply as a stick frame, light framed building, and the Connecticut Housing Finance Administration agreed and gave us a low income tax credit to do it. And that's the story of this building. And it's going to be nice. And it's clear that if you can basically design a structure that's appropriate to these new systems, which have huge benefits, you can create a really, really durable structure using carbon storing materials, which perform at a really high level, and you can create much more dense cityscapes and really good interior quality spaces for people who really just don't have access to housing. So here's the thing. Photosynthesis is an amazing chemical reaction that with very little energy, and all entirely renewable solar energy, and just happening to use large surface areas of the planet, we can generate a lot of building material. And so we built a little school in New Haven, Connecticut, 20,000 square foot common ground high school, a school founded by foresters from the Yale Forest School, all out of bio-based materials. And we watched for 3 months as the concrete foundations were put in, and then all the material arrived from Nordic Structures in Quebec via Benson Wood in New Hampshire on site, and 3 carpenters and 1 crane operator built an entirely enclosed building, airtight building, in 5 weeks. And the students love it, and we don't use steel and concrete fire stairs, we use timber bridges for egress. The students tell us that they love the way it smells, which I think is a really good design criteria for architects, make a really good smelling building. And all the students there, these high school students, can tell you pretty much within 50 miles exactly where that wood was harvested, and this chain of custody question is a really important one. None of us can tell you where the gypsum was mined to make the wallboard here. And really, essentially what we've done is created an example of how to look at the entire value chain from our friends up at Nordic, who helped us really to make an affordable school, working with constituencies in the school, but also at the state to help us do this, to build that supply chain. And to really understand that we can trace much more easily the materials that go into our buildings from the forest in which they grow, and we can also really understand that when to harvest optimally those particular species given the goals of the regenerative silviculturists who are working in them, and how much carbon would be stored, and how we actually map potential products, not just mass timber, but insulations, claddings, finishes, onto the buildings that we want to make. And then literally count how much carbon is stored in them. And if a 14-year-old kid can analyze a building arithmetically and tell us that in this building, there's enough carbon stored to offset 100 cars' annual emissions, I think our scientists and policymakers can also do the arithmetic and see the potential benefits. And so, where I teach at Yale, at the Yale Building Lab, we try to model this for our graduate students. They're mostly going into architecture, although a number of them are going into forestry and environmental science and things like that as well. And we actually look at ways to think through the things we make, to learn what builders and foresters and policymakers and financiers have to deal with. And we do that through a lot of different tools. Obviously we're testing different materials, not just wood, but also soils that are, waste materials coming out of construction sites or mining to make structural bricks that have certifications for building. We're also looking at regional forest flows with our colleagues at the Yale Forest School to try to understand exactly what species at what time will be coming out of what forests and how can we put them into different innovative structures. We do a lot of advocacy work. That's Tom Vilsack, Secretary of Agriculture, talking to 14 graduate students about timber building in 2014. And we also really pay a lot of attention to the act of making a building. And so I want to show you this one quick project, which was student built during COVID. We were the only design build student project in the country going on. We created a little pod, and we worked with the Peabody Museum to design a coastal research station for their scientists who are working on an island off the coast of New Haven. And the whole thing was really conceived as a prefabricated, modular, fully integrated, off-the-grid building. 14 students from the School of the Environment and the School of Architecture. Fully prefabricated, optimized materially in a factory building, actually an old trucking depot. Really novel kinds of assemblies that would serve multiple purposes, solar photovoltaic arrays, daylighting. We salvaged material from the fire safety tests for CLT and turned them into buildings. We had to do a little work on them to make them nice. We built the entire building off-site, just so we could rehearse how to actually put it together. We packed it up. We shipped it to the site. This was the most difficult loading dock I've ever worked with. Our students went in with the foresters at Yale. We went into this site, sassafras grove, and we were told there's this thing called high grading, but you're going to do the opposite. You're going to find the trees, the sassafras trees, which have good rot resistance, and you're going to take them out to support the other healthy forest species and ecosystems. And they remove them, and they process them, and they learned how to actually take roundwood, and guarantee that it would serve durably in the locations that they were going to be applied. And we built skylights that also served as photovoltaic arrays. And in the end, sorry, you guys. We made a building for scientists and artists who would live, stay, work. Classes would come. Muckety-mucks from the Yale board would come and experience this incredibly beautiful island. And to do it in a way that was understood to be a result of incredible transdisciplinary collaboration across the building value chain to produce a space for people to stay and live and to learn. And there are a lot of lessons we learned from this process. But what we learned was we can replicate that at a regional scale. It doesn't just have to be in a university, because we can build the networks that we need. So we went to work with the U.S. Forest Service through a Wood Innovation Grant to look at exactly how we might create innovative structural responses to the flows of materials coming out of northeastern forests. So we looked at this incredible woodshed that exists in the Northeast. And we looked at those huge demand centers along the coast that are going to be asking for materials from someone and somewhere. And we looked at the capacity of those different states in aggregate to provide material for building. And then we looked at the way those materials would flow, say, out of Maine, which is the sort of mother of all forests in the Northeast, and how they'd applied in building. in cities like New Haven or Boston or Providence. And we evaluated those flows and the volumes of those flows, and not only looked at them for the typical things like appearance, but rather hardness, tensile capacity. And we mapped them onto specific building assemblies. And then we went to work trying to think of a specific example of a building assembly that would actually substitute for steel and concrete. And we came up with this pretty cool idea for a cassette using cross-laminated timber, not necessarily produced in New England, doesn't have to be. That was used different species, white pine, some hemlock, but also hardwood dowels to create this incredible structural assembly that was like a space frame. And it was robotically produced. So from the flow of material into an assembly, into a system of structure that could produce a 10-story tower, fully engineered. And then designing all of the tooling that would make that possible for, say, a small woodworking manufacturing company to invest with minimal capital expenditure, not build a $28 million CLT plant, but create a distributed economy of people who might use robots or CNC mills to coordinate an entire economic network that would supply parts and pieces to builders through a coordinated building information modeling system. And so we started small, and then we worked up, and we started building these systems. And today, this is about to go, this is a product that will be delivered. And it was produced with a KUKA robot, a used recycled KUKA robot, and it will produce assemblies that can span 28 feet in one axis and 10 feet in the other. Actually more, but you can only fit 10 feet on a truck. So I'm going to give one last example. Moving from Yale to the city, to our region, and out to the country scale, the nation scale. This is a project we're working on to revamp the entire supply chain of building it in Bhutan. For those of you who aren't familiar with Bhutan, it's a tiny little forested Himalayan country north of the Bay of Bengal. It's got about 750,000 people. In land area, I think it's half again the size of Vermont. And it has incredible forests and incredible building traditions using rammed earth and timber. But because of the boom in building that's happening in Bhutan, the capital city, Thimphu, is the fastest growing Asian city, believe it or not, per capita. There's a lot of reinforced concrete building going on in a highly seismic zone. Really poor quality building performance. 90% imported labor and material. And so the building sector and housing starts, which are in our economy a driver of economic prosperity, is actually a drag on the gross national product. And so His Majesty the King and the government invited me and a number of colleagues to actually build a system change program, which is, look, we got all this incredibly beautiful forest. It's suffering the same kinds of stresses that all forests across the planet are suffering. We've constitutionally mandated that we'll maintain 60% forest cover across the entire country and reserve those forests. Could we develop a mass timber industry and bio-based construction industry? And in so doing, could we rebuild an entire building culture for the young people of Bhutan so that they don't go to Australia and India to get jobs? So we were trying to build literally an economy through building. And we did an investment case. We looked at the demand of different cities in the country, material demand. We looked at the capacity of the different forests, which are management units across the belt of the country, and how they could supply those cities. We developed really specific glue-laminated timber structural systems and entire building assemblies for both office space and for housing. We did not use CLT. I'm sorry for those of you guys who want to build a CLT plant in New England. We just found that glue lam could do all the work that it needed to do for a country like this at a quarter of the capital expenditure. And we worked with Ledinek in Slovenia to design a facility. And we designed the architectural systems and the kit of parts for log depots where the primary processing would happen so that we weren't bringing logs into the city. And we started training a whole group of young Bhutanese people in forest practices, silvicultural, regenerative silvicultural practice in construction, site supervision and management, in factory with millwrights, in finance, real estate development, the building regulators that already exist in the country. And this system change program was not just about a single point intervention, an investment in one product, which is going to save everybody. We recognized that we had to train a lot of people, including people already working in the system as well as young people. And we had to create those opportunities to not only protect the forest, but incentivize its protection through building demand. So we designed this structural system that is a type that's now going to be deployed across 1.5 million square feet of government-sponsored building, working with Bhutanese architects who are doing all of this sort of architectural styling, that's not right, given the appropriate traditional expression. And there's the king in the red, looking at the model with our architectural colleagues who are going to work on this project together. So I'm advocating, in conclusion, a design sensibility that isn't just about architects and engineers, but actually everyone along the entire building value chain. And I'm not saying we're going to design ecosystems. I'm saying we're going to design ecosystemically. Thanks, everybody, for your patience. We know how to do industrial harvests. That's not what we're talking about. We're talking about getting feedback from all of you about what's happening to the forest and what can the forest provide us, rather than telling it what species and what size and what quality we want from the forest. What can the forest give us? And how could we possibly use the criteria for good ecological silviculture as designers of buildings rather than designers of forest conservation? To deal, if we asked ourselves as architects, how would we actually reduce invasive species in a given forest? Or how would we improve water quality in a given forest by a design decision and a material specification? That would be ideal. But we can't do it with the forest alone. Forests have to work with waste flows to create circularity, to support and supplement forest flows from industrial, consumer, construction, waste streams. We have to learn how to process these materials, whether they're wood or not, so they're healthy for people who are going to live in the buildings with which we build them. We have to think about not only designing for assembly, but also for disassembly, so at the end of the building's life, we can actually take the building apart and reuse as much of it as possible. But not only that, but we also have to develop scenarios for those reuse. 70 years from now, I have to try to tell you what that piece of wood could do for some future builder or other consumer product manufacturer. And by the way, we can't get this done if all we do is tear down buildings because we can't figure out how to use them. We have to protect our existing building stock. And that means the buildings we hate as much as the buildings we love. Because these buildings, the buildings which we built 40, 50 years ago, but we can't stand and we can't figure out how to use them, these are the ones that are going to create incredible impact when we take them down and we ship all that material to somewhere else, or we cover the land with landfill. Not just trees, ag waste, anything we can think of to use to store carbon. We did a study in Europe, that in Eastern Germany, that if we recovered what had been peatlands in the east of Germany from typical agricultural conversion, we could actually reduce Germany's emissions by 25% because of that carbon sink that would be created in peatlands. But we had to design the products from taifa grasses and different kinds of reeds that could be applied to building to incent that. We have to stop building sprawl. We have to build convivial, dense, efficient human settlements. I'm not saying we've got to stop building beautiful houses out in Vermont, don't worry. What I'm saying is that the cities have to be more efficient. They have to prize really good design, because when you create convivial density, what you do is create really efficient infrastructure. You incentivize mobility services like mass transit. You have much fewer impacts, and I think you probably create a healthy community. And we have to break this relationship that exists between dense urban building and fossil-intensive hydrocarbon manufacturing of the steel and concrete industry, and break that equally insidious relationship between suburban low-rise sprawl and forest consumption. We can govern state by state, but really what we need to do is think bioregionally for all the benefits that come out of it. And I want to talk primarily about the economic benefits. We create, through this incredible breakthrough in the construction sector, we create entirely new classes of urban employment and enterprise, not to mention rural workforce and enterprise opportunity. And we actually can imagine that you don't need one manufacturer to produce all of the mass timber that goes into an 18-story building at Brock Commons at the University of British Columbia. Certain manufacturers could produce any of those parts, and we could coordinate through our networks an incredible supply system, not a vertically integrated one, but a horizontally integrated one, and take advantage of the technologies that we have right now to design and coordinate construction. So small guys, I say guys, men and women, small shops could actually be part of a supply network and not have to worry about a $50 million capital expenditure. So I'm going to close. Thank you for your patience with my fumbling. I guess really what I want to say is this is a really, really hard problem. This is one of those diagrams you're supposed to look at but not really pay attention to. It's just supposed to convey complexity, because it is complex. But there are a bunch of decisions. Above that black line, there are decisions about design, starting with even land selection or material specification, that will produce carbon emissions. And then there are a bunch of decisions all along the way, all along the entire pro forma of a building, that will produce carbon storage, and we can learn how to do that. 350 million years ago, at the end of the Middle Devonian, carbon concentrations were incredibly high. And some little biotic activity happened, and then we started getting these big fern-like trees, and they started to draw carbon down really quickly. And there were no biotic organisms to consume them, so they just stacked up, and they compressed over geological temperatures and pressures to create fossil hydrocarbons. But forests gave us our lives. Forests are the progenitors of human and all species lives. We have thumbs because we climbed in trees originally. And then, Industrial Revolution rolls around and we start digging up that stuff and emitting it through this sort of so-called fugitive carbon into the atmosphere. And it only took 150 years to get us into this situation that it took 350 million years to solve initially. So the question is, can we more quickly, through coordinated activity and all of the different techniques and tools and methods, actually start to reverse that and create a decarbonized future? And I think the materials that we have in this room and that you guys work with every day in your work will be the primary means to do it. I don't know if there are any German speakers in the audience. Aus dem Holzweg means literally on the wood road, but it's a really derogatory thing you say in Germany. If you're like on the wood road, if you're auf dem Holzweg, it means actually you're lost. I would like to recapture aus dem Holzweg, on the wood road, as a means to save our planet. Thank you. Okay.
If anyone wants to ask a question, does anybody have any question or thoughts for Alan? Got a few minutes?
You're overwhelmed.
Anybody? Oh, yes.
Yeah, I'm not sure it's today. questions, well, not so much questions, but all the talk of wood being better for the environment, and nobody even mentions the glue.
Yeah. Yeah, well, that's why our fully mechanically assembled structural system the goal was no glue. So they were nail laminated, cross-laminated timber, and they were dowel laminated, robotically drilled and robotically removable dowels. And we tested it, and as I said, it has real capacity to span, and it took one robot setup and a track. So, I would say that investment is probably about $100,000. Significant, but not 57 million. And I get asked a lot about adhesives. I mean, they're fossil hydrocarbon-based plastics. They're resins. They will last forever in ecosystems when the buildings are long gone. And I think we just have to look at the counterfactual, which is that even recycling steel has enormous emissions associated with it because you have to melt it, basically. And I have colleagues who are working on different methods of reducing those impacts, but they are impacts. And what we're trying to do is subtract. So yes, we can reduce, but how do we compare different options? And I would say the efficiency of glue in glue laminating is so small compared to the impacts associated with sintering Portland cement that we have to keep that in mind. And at the same time, solve it so that we're not using fossil hydrocarbons to glue our sticks together, which we'll never be able to take apart. There's incredible technologies being developed in lignin-based glues, so bio-based glues, which will reach structural capacity, I think, within the next 5 years. So you're absolutely right. There's a lot of glue in there. Certain kinds of structures use way too much glue. They're mostly plastic, but I think we're heading in the right direction. That's a great question, though. Thank you. Yeah. No, it's really important. Well, you all know that, what we're cutting away, crowns and material that's, stays in the forest and contributes to, some carbon emissions as it rots and some below ground storage of carbon in the forest. Every time you process a piece of wood to a next more refined stage, you have this, waste flow coming out of it. The timber industry's pretty good. Manufacturers are good at using those things. They pelletize some of it and they use it to run their kilns to dry the wood. Hull Forest Products in Pomfret, Connecticut actually supplies the local school with wood pellets to run their heating system. And then there are a bunch of products that we couldn't have even imagined 50 years ago, like oriented strand board, where we take all of those waste materials and we actually produce products, and we create such demand that we actually now have to chip wood to make them. So there's a bunch of balancing going on. And then finally, as I mentioned, the wood that's going into most construction sites, because we buy wood and we build the stick with sticks on the site, is actually wasted. So we have to think how industry, like pre-manufacturing, can produce products that are cut to size and optimized material in really good workplaces, safe work environments, so that we reduce waste and optimize material. And we have to teach architects how to not make crazy shapes that create a lot of waste of wood material. So it is, again, a systems answer to your systems question, which is there's a lot of waste. How do we direct that waste to the highest and best use, whether it's to create habitat in the forest, or store carbon in the forest, or to create some byproduct of a manufacturing industry.
Fantastic presentation. Nice to see you. Can you discuss a little bit around the role of like certifications and chain of custody control and whatnot that's been a bit of a bottleneck in some ways from trying to connect good forest resources to sustainable buildings?
Yeah, thank you. And you're more expert in all of that than I, so you may have to take over. But what I've seen both nationally and also internationally is this huge challenge, which, as one colleague of mine in Quebec said, mills are giant walls that we can't see over into the forest. We have no idea what's happening behind those accountants' walls, like what wood is coming where, and that's why the work of Cambium and so many other really interesting groups are looking at how we can trace chain of custody to guarantee how the forests that are being harvested or managed, what they're doing to the forest workers, all of the forest stewardship goals that we have for good forest practice and good building practice. We're seeing different technologies that are contributing to this, so DNA tracing of wood, blockchain technologies, I'm sure, will play a role in all of this. The certification standards are spotty from country to country, so we could have a really high standard in Austria, but we're actually getting wood from some Romanian, forest preserves. So this tracking is really, really important. I was really taken with the thing that you told my class at one point, which was you were harassed about using straw bale material as an insulator because of fire, and you said, well, you're pumping, fossil hydrocarbon, highly combustible foams into all your buildings, so I think we can solve the circumstantial barrier of how to protect straw as a potential insulative material. And I think that's really, this may not be answering your question, Jacob, but I think really what we're focusing on is how to build the technological solutions that are fully vetted and certified through different country or state or regional appropriate certification systems. And they're all different, but they can draw information upon them. So in Bhutan, as an example, we're building a regulatory code for timber building, which is based on optimizing a European code, an Asian code, and the International Building Code in the US to try to get a better version of those codes for Bhutan. And that will include source to supply chains so that it's fully documented. And I'm not expert in this, so as I say, I'm kind of fielding a question which I'm ill-equipped to answer. But it is true, and I hope that's the conversation today, that the regulatory structures that exist are both too controlling and they misunderstand material properties. And I can't tell you how many times, I'm sure you've heard this too, that wood burns, so you can't put it in a big building, which is just one problem, which isn't just the general population has fears about it, but building regulators in the city of New Haven worry about that too, justly. But there are answers, and they're good answers to it, and we have good testing and proof of that.
Wood is such a wonderful thing to work with and harvest. However, there's a problem of cutting trees. We have an urban population in the United States who are just totally against the harvesting of trees. And it's more so in the United States than it is in Europe, and more so than it is in Canada, where they understand the natural resources because it's so dependent on their lives. And we have a whole generations of young kids who have been taught in our school systems. They never talk about forestry. They never talk about the wise use of the management of our forests and the benefits that we get there, and that we also have these people that manage our forests. And we have a whole environmental industry that makes a living on pushing half-truths, mistruths that we're also up against. Look at our forestry schools. Our forestry schools are closing because when high school kids go and talk to the guidance counselors about, well, I would like to work in the woods or something like that, guidance counselors say, it's a dying industry. They're being told that.
Yeah.
There's a lot of gray-haired foresters in here, myself included, and we're looking for young foresters to bring along, nurture along, and they're just not there. So we have a real educational situation that we have to deal with because we're going to be against that. Yeah. Look at how they shut down the Massachusetts state forests to harvesting.
I know.
Connecticut, it's the same thing as well.
Yeah, your You're preaching to the choir here, I have to tell you. That was the intent of that giant picture from the 19th century of that redwood log, which is the nightmare scenario of most people in this country. That we're going to somehow decimate the forests if we use productive forestry to create buildings to meet the building demand that we have in this country, which is huge, huge. So there was a great study by the Nature Conservancy run by Mark Wishney, who's now at BTG Pactual, doing plantation forestry, which has also proven to be really beneficial ecosystemically, by the way. Another mystery for most people. And they looked at this question of social license. Like, what do people think of building with timber? Well, they believe that wood is the most sustainable material by far to build buildings. That wood is sustainable. But the timber industry and forestry was considered the least sustainable of all the materials that were used to build buildings. And I think that tells us the problem that we face right now, which is exactly as you say. But that education has to start really, really early. It's not just the people who go to forestry to go to study forestry at Yale or wherever. It's actually kids who are given access to the forest and understand how forests grow and die and what that means and how that can be actually gamed in a really sustainable way to produce forest products. But I will tell you, every mass timber building that has been built successfully in the US and in Europe is rented or purchased quicker than any other building material class of buildings. And that's because people go into these buildings and they're like, wow, we feel good. And there's actually scientific evidence about stress reduction, cortisol hormone reduction, lower heart rates for kids who go to school in wood-lined classrooms. So it's got to start there. I don't think the forestry schools are going to be able to answer this problem, but I do think the entire educational system can start to address really rigorous study of nature-based systems and how they function and how we can actually work within them as an ecosystem, as part of that ecosystem.
The point about the forestry schools was that they're closing because they don't have enough kids
Yeah.
getting into this program.
No, we saw it at Yale.
Are in high schools and they're studying environmental studies.
Right.
So this is actually a good segue to a larger conversation that we're going to have in just a few minutes. We're at time, so we're going to wrap this segment up. And I just, please, if we could give Alan some applause. Hang on, wait, don't go anywhere.
Amazing.
So this is just a small token of appreciation. This is actually a print that's made by an artist, Katie Babick, who's somewhere in this room. Katie, where are you? Are you around? I don't know where she went. Maybe she stepped outside. But anyway, Katie is a really talented artist that uses the cookie of a tree to make these beautiful prints, and so we wanted you to have this one as a commemoration of you coming up to Vermont.
Thank you.
Enjoy it, and thanks again.
My pleasure. Thank you, guys. It's beautiful.
So we're gonna take a 15-minute break, and then we'll come back, we'll reconvene, and we will kick off our plenary. Please go visit with the exhibitors and have a cup of coffee.